Welcome to the video series Learning to Fly My Homemade Helicopter. Unlike part 1, the wind is calm today, but there's still a slight slope, this time sloping forward. With the CG aft, we'll see how this goes. The first bit of knowledge I've gained is that a wind gust will affect the helicopter vertically, so sudden changes in lift occur without input from the pilot. From now on, I don't see much point in testing it in anything other than calm conditions. This might seem obvious, but it's good to know the exact effect that wind has on a helicopter. Okay, so this is the first test of the day, and it started just like part 1 where I'm pulling too far back on the cyclic and I'm really not controlling the throttle with much precision. The tethers are doing their job and saving me from incident, which would have likely been the result straight away without them. I get the rear skid hung up here and I tried to power off, but it didn't work, so set it back down. I'm trying to get a feel for the position of the fore and aft cyclic, but as in all helicopters it's sensitive. I finally find the position fore and aft, and then the roll position is too far to one side. Getting a feel for where the cyclic is central has proven difficult, but as a helicopter flying student I understand it's going to take time. I need to stop as the engine is getting hot without any radiator fan now.
I've had many comments about the CG being too far aft, and in part 1 it certainly looks like that's the case, so here is how I'm checking it. As you can see, the inclinometer is reading 0.15 degrees tail heavy, which is very close to level. If I hang a 5.5 kilogram weight on the front, the CG becomes 1.8 degrees nose heavy. I'm going to go and try this now. I thought the balance might have been slightly better, but I think only a side view will show what I'm doing with the rotor tilt. Unfortunately, I didn't film this angle, but I will do next time. I got a chance to test the yaw vanes and they seem to work okay. I can certainly point the helicopter in the direction I want it. I'm not at full throttle at any point during these hovering attempts, and I would estimate I have 10 to 15% still available. If I wanted to, I could make the helicopter come up to the top of all the tethers, but I'm too nervous to try that at the moment, and it would only prove the lift capability. The throttle or lift control certainly has a delay of perhaps a second, particularly when reducing the lift, which means things get worse before they get any better. And if you overreact, it comes back down with a bump. It's going to take me a lot of hours to learn how to fly this machine, but you're going to get a step-by-step videos of the process with my thoughts and struggles. Please comment with thoughts and suggestions, I read them all, and it'll help you to decide which approach to take. I do love the sound of synchronous belts, by the way. It gives a lovely transmission whine in my sad engineering world. I've decided to make a conscious effort to be extra gentle with all the controls and treat it as if I didn't have any safety tethers. I also decided I wasn't going to react so violently to throttling off. I have had a lesson in R22 in the past and felt like the collective reacted quicker than my helicopter, and this is no surprise, but it's going to make learning to fly this thing harder.
If I wobble this blade, the other one wobbles the same. If I stop, the other one stops. Bit of an odd thing. Look at this, look. All the bugs. The tip of this blade is going at 400 miles an hour. I don't think they stood much chance. If you haven't seen part 1 of this video, then that is totally out of order, but it's okay, you can see it here. And if you want to know more about the build, then there's a bunch of other stuff on my YouTube channel. Cheers!